This video will help you review the laws of motion and how they apply to your air dragsters that we built in class. You're going to use this review to help prepare you for the summative reflection after we race. You're going to have to answer some questions about your car build process and how your race car followed the laws of motion. Starting off, we're going to look at our first law of motion. We know that there are two parts. We know that there's objects at rest and objects in motion. Starting with objects at rest, this takes place at the start when the car is on the launcher. It is just going to sit there forever until we provide an unbalanced force to make the car move. In this case, the air provides the unbalanced force to launch the car. And that happens because the air moves through the tube, hits the back of the air chamber, and starts this chain of events that we're going to talk about while your cars are racing. So with objects at rest, it's going to stay there at the launcher until the air provides that unbalanced force. When we get to the cars moving down the track, that's where our objects in motion part comes in. We know that they should stay in motion at the same speed and direction unless acted upon by an unbalanced force. And if you recall, when we rolled the cars down the floor in the middle of the classroom, when we first introduced the laws of motion, we know the cars change directions, they hit desks, they did not make it all the way through, and most of the time they slowed down before they even touched anything to begin with. That means that there are definitely some unbalanced forces in play. So we have three main ones that we're going to talk about. The first is gravity. Gravity actually pulls the car down onto the floor or the track, which then causes it to hit those bumps and imperfections on the surface that causes this car to slow down. We also have friction. There's a couple main places of friction. One is the wheels and the track together. That is how gravity affects the car because it pulls the car into those bumps. Those bumps hit the wheels, which slow them down. But we also have friction with the axles and the body of the car. We put the straws in there to reduce that friction as much as possible, but we still have a little bit of friction there because the axles are rubbing against the plastic straw. The last main unbalanced force we have that causes our cars to slow down or change directions is air resistance. We talked about how the air flows over the block, and that's why we wanted to have as smooth and sleek design as possible. We didn't just want big square blocky corners. We wanted to have something that was going to allow the air to flow over your car with as little resistance as possible so it did not slow your cars down. So here's objects in motion once again. You have gravity, friction, and air resistance all working together to slow your car down and causing it to change directions before it gets to the end of the track. When we get to the second law of motion, we know that the second law talks about acceleration. It happens when force acts on a mass. And we also know that the greater the mass of an object, the more force you need to accelerate it. With that came that law that we're familiar with, force equals mass times acceleration. That works great for finding how much force you need if you take your mass times how fast you need to accelerate. However, we don't know the acceleration rate, and we don't really know the mass of your cars because we haven't weighed them. The one factor we do know is force. We know that both cars are going to have equal force applied to them in the air pressure. That pressure we know that both is going to get is 75 psi. So both cars receive the exact same amount of force at the exact same time. So what that changes ours into is instead of figuring out F equals ma, now we're trying to figure out how mass affects acceleration. But the force is the same. That's kind of a non-factor now. The one factor that's going to affect acceleration the most is the mass of your car. So you see we have two different cars here on the screen. We have the top one, which is basically the plain block, and the bottom one, which we've cut more out. Due to this law of motion and the force being equal, we know that more mass is going to mean a slower car. We know that less mass is going to be a faster car. That is because that 75 psi, that force on the lighter car, is doing less work to get it going. So more of that force can be used for just straight out speed and to carry that car down. It's much more efficient. On the heavier car that has more mass, that 75 pounds of force is being used just to get it moving. It doesn't have the chance to accelerate as quickly because more of that force is being used just to move the car. So that's the second law. Again, it's the same force on both cars. The big difference in acceleration is going to be the mass. The more mass you have, the slower your car. The less mass you have, the faster your car. For the third law of motion, it takes place in two main spots, at the start and at the finish. At the start, this is kind of returning to our first law of being at rest. We said in the first law that air provides the unbalanced force to make a move. That is true. It's what happens after the air hits the car that involves the third law of motion, and it's what actually makes the car go. They work together in this case. For the third law to happen, we know that every action is an equal and opposite reaction. So first you have to have your action and reaction. They're going to be of the same amount of force, but we have to have the action and reaction. When this happens, someone will push the red launch button and launch the air into the car through the tube. That air is then going to hit the end of the air chamber and cause it to push back out the back end. This is the action. So the air pushing out the back end of the car is the action that happens to push with 75 psi. The reaction comes in, and when that air is pushing out backward at 75 psi, the reaction is that the car moves forward with the same amount of force. So again, the action, the air hits the air chamber, pushes out the back end, that causes the reaction of the car moving forward the same amount of force. So air moves out the back, the car moves forward. That's the third law at the start. We also have third law at the finish. At the end of the track, there's going to be some foam blocks for your cars to hit, so hopefully they don't break. While the cars are running down the track, okay, they have a certain amount of force. So for the action part, the car has to hit the end of the track with force. That force is going to vary from car to car, from race to race. Your car might be doing 4 different races, and that amount of force it hits the wall with will be different every time. That amount of force depends on a couple of things. The mass of your car, how fast it's going, how straight is it hitting the wall, is it kind of sliding sideways, has it bounced off the walls of the track and slowed down. A lot of factors affect how much force it has when it hits the wall. But no matter how much force it has, the action and reaction that takes place is the same. The amount of force that the car hits the wall with is the same that the reaction is going to apply to the back. So if your car hits the wall and it is fairly straight, when it does the reaction, it's going to bounce back pretty well straight down the track and roll right back toward the start. If your car is hitting it slightly crooked, then when it does the reaction, it's going to fly off at an angle or sometimes come completely off the track. Okay, how that reaction applies to your car and what it does depends on the angle at which it hits the end of the track. But the force is the same. So however much force your car hit the wall with, that same amount of force in the reaction is going to cause the car to come off of the wall, either rolling down the track or flying off the track entirely. Okay? So that is our laws of motion and how they apply directly to our air-powered dragsters. You will need this information again at the end of your reflection is the last part of your project reflection. After you've told me about the design and build process of your car, you're going to have to tell me how the cars worked on the track. So while we're testing the cars and racing the cars, make sure you're watching for that, and I'll point that out as well. Hope this helps you. Study this so you're ready for the summative reflection, and we'll see you in class. Have a good day.